today we are going to be simplifying rational expressions. And to do that, we are going to have to factor until we cannot factor anymore. So part of this lesson is going to be a review of factoring techniques. All right, so to factor a general trinomial, ax squared plus bx plus c, when a equals 1. What that means is, like if you had x squared plus 5x minus 6, okay? A has to be 1. When a is 1, it's very simple. It should be an easy factor. You look for a GCF if there is one, which if a is 1, there shouldn't be. And then you have to find all the factors of c. Well, my c is 6. All the factors of 6 are 1 and 6 and 2 and 3. These both can make 5. I can make 5 here if I subtract. I can make 5 here if I add. This doesn't happen very often. Occasionally, you can make b more than one way, not very often. C will tell you which pair you have to use. Only one of them will give you the right factorization, okay? Because c is negative, I need the subtracting pair that will make 5. So what you do then, those are going to be your two factors, 1 and 6. And those are going to go there every time. And then it's always, when a is 1, it's always x and x, because what you're finding is two things multiplied together that equal that. Well, the only way to get x squared is to multiply an x by an x. So that has to be x and x when a is 1. Okay, and then again, I found my numbers, so those go in there. Now again, for the signs, are they both positive? Are they both negative? Is one positive, one negative? And how, if one of each, how do you know which one? C will tell you. If C is positive, then they both will get the sign of B. If C is negative, then only the bully will get B. So my C is negative, which means my bully 6 will get the sign of B. So the bully gets to be positive and one's going to be negative. Okay, and we factored. Okay, x squared plus 5x minus 6 equals x minus 1 times x plus 6. Alright, so let's try another one. We've got a is 1, so it says you find all factors of c. C is 8, all factors of 8, 1 and 8, 2 and 4. The only pair that will make 6 is 2 and 4. So when I write my binos, x and x, my two numbers that I figured out are going to be 2 and 4. Since c is positive, then they both get the middle sign. So they're both going to be positive. And it's factored. Okay? And if you look, you can see that it crosses at -2 and at -4, which if I solved this, that would be where the zero showed up. Now, we're not finding the zeros, we're just finding the factors. But again, I like to tie everything together and give you a visual of what it was that you found. Alright, so if we try another one, it says find all factors of c. My c is 18. Yes, it's negative, but I don't care about the sign because both or bully will take care of it for me in the end. So factors of 18, 1 and 18, and that can't make 3. 2 and 9 cannot make 3. 3 and 6 can make 3. So in my binomial, my two numbers are going to be 3 and 6. Of course, it's going to be x and x for x squared. C is negative. If C is negative, only the bully gets the middle sign. So bully 6 gets the positive, 3 gets the negative, and again, what you're doing is you still have x squared plus 3x minus 18. You just wrote it as a product of two factors. Okay? Alright, and if you can see, if I actually solve those, x would equal 3, x would equals -6. There's your -6, there's your positive 3. Alright, so you try this one. Come back when you're ready. And hopefully you got number 2. If you did not, let's look at y. Okay, a is 1, so it's going to be an easy factor, x and x. Factors of 42, 1 and 42 will not make 13. 2 and 21 will not make 13. 3 does not go in. Oh, 3 and, what is that, 12? 14. That won't make 13. Right? 3 goes in there 14 times 1. Yeah. That didn't work. 4 and doesn't go evenly. 5 doesn't go evenly. 6 and 7. And that's the pair that's going to make 13. So 6 and 7 goes here. Since C is positive, they both get the middle sign, which is negative. And there's my two factors. And again, if you see, it crosses at positive 6 and positive 7. Alright, difference of two squares. Difference of two squares only works if the two terms, first of all, it has to be a binomial. This cannot be a trinomial, so there can only be two terms. And they both have to be perfect squares, and the middle sign has to be a minus. There's no such thing, well there is, but at this point in your life, we don't factor sum of squares. Okay, there's the factorization of it, but we're not going to be interested in that today. And the song goes, bino, bino, plus and mino. So if I had x squared minus 9, okay, it's a bino, check. They're perfect squares because the square root of x squared is x, no remainder, or no left in. And the square root of 9 is a real 3, no decimals. So the perfect squares and the middle sign is a minus. So it all checks out. And if it all checks out, then this will factor into bino, bino, plus and mino. And then these are the terms that go in there. X plus 3 times x minus 3. I think you probably remember difference of squares, but alright, so again we have difference of squares. It's a bino. The ends are perfect. And it's a minus. So we have difference of squares, which means bino, bino, plus and mino. And to figure out what the terms are, you just basically take the square roots. The square root of x squared is x, so that goes first. The square root of 4 is 2, so that goes second, and we have factor. Okay, for B, it checks. It's a bino, two terms. It's a difference, and these are both perfect squares, because the square root of 81x squared is 9x, and the square root of 49 is 7. So bino, bino, plus and mino. And your two terms that go inside are 9x and 7. And I factored. If you multiplied that back out, you'll get 81x squared minus 49. Alright, and if you look at this one, it crosses at positive 2 and negative 2. And if you look at this one, it crosses at positive 7/9 and negative 7/9. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got number 2. It is a bino, it is a difference. These are perfect squares because the square root of x squared is x. The square root of 100 is 10. So bino, bino, plus and mino, and those are your terms. X plus 10, x minus 10. Alright, and if you look, it crosses at positive 10 and negative 10. So, why did we review all that factoring? Well, the first thing that your homework's going to ask you to do is solve proportions involving polynomials and numerators and denominators. A proportion, remember, is when you have fraction equal fraction. And so what you did, remember, was you cross multiply and divided. You did this times this has to equal this times this. You're going to do the exact same thing. There's just one trick. Instead of them just being plain numbers, they're going to be polynomials. So first of all, you want to factor every single numerator and denominator that you can and eliminate fractions, okay, if you can. Then set cross products equal to each other and get the question mark alone. Alright, so basically they're trying to figure out what the top would have to be. Well, again, I try and factor every numerator and every denominator, but in my first example, everything's a monomial, so nothing can be factored. So I'm ready to solve the proportion like you learned a long time ago. Product of the extremes, so 2 times 12x cubed, has to equal the product of the means, which is 3x times my question mark. Now, to get my question mark alone, we're going to divide by 3x. And that will get my question mark alone. Now, to simplify this, we have to distribute on top, which is going to give me 24x cubed, divided by 3x is going to give me 8x squared. So my question mark equals 8x squared. Okay? Alright, over here, again, remember the very first rule. Factor every numerator and denominator that you can. The top of this one can't be factored. It's the first degree. It's prime. The bottom is a monomial. Can't be primed. The top here is difference of squares. So I am going to factor it. It's going to split into bino, plus and minus. And my roots are going to be the square root of x squared is x. The square root of 4. Oh, my bad, Tamsin. Sorry, that is not difference of squares. That's got an x on it. Oh, I'm so bad. So GCF on this one, I can pull out an x. If I factor out an x from there, that's going to leave x minus 4. So now when I do my cross multiplying, I have x minus 4 times the question mark equals x times x times x minus 4. And I'm not going to multiply that all out yet. I'm going to wait and see what cancels, because if I try and get my question mark alone, I'm going to have to divide by x minus 4, which cancels here and cancels here, which leaves x squared for my question mark. Okay? Alright, so you try this one. Hit pause, come back when you're ready. And hopefully you got number 3. If you did not, let's look at why. Okay, I'm going to factor everything. Obviously, the question mark can't be factored. This bottom is difference of squares, so it's going to be bino, plus and minus, x plus 3, x minus 3. On top here, it should be an easy factor because a is 1, so x and x. Factors of 6 that make 1 would be 2 and 3. Okay, c is negative, so only the bully gets the positive, so bully 3 is plus and 2 is minus. And the bottom is a binomial, but degree 1 can't be factored anymore. There's nothing in common. So now, to do my cross multiplying, I'm going to have question mark times x minus 3 equals, the other way is going to be an x plus 3 times an x minus 3 times an x minus 2 times an x plus 3. So to get my question mark alone, I'm going to divide by x minus 3. And my question mark is, those cancel. So it's x plus 3 times x minus 2 times x plus 3. And you're going, how in the heck did they get that? They're not wrong, and neither are we. It's just our answer is in factored form, and their answer is in general form, standard form. So we just multiply 2 at a time. I'm going to drop this one down later. X times x is x squared. X times negative 2 is negative 2x. Positive 3 times x is 3x. Positive 3 times negative 2 is negative 6. Combine like terms. I get x squared plus x minus 6. But I still have to multiply that by this x plus 3 factor. So if I do that, I have x squared times x is x cubed. X squared times positive 3 is positive 3x squared. And positive x times x is positive x squared. X times 3 is 3x. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. Combine like terms. There's no other x cubed. 3x squared plus 1x squared is 4x squared. 3x minus 6x is negative 3x, and the negative 18 drops. Okay, we were not wrong up here. This is just what my answer is in factored form instead of general form, or standard form. Alright, so now they're going to get more complicated factoring. How to factor when A does not equal 1. You're going to look for a GCF if there is one. Then you're going to do A times C, find all the factors. Rewrite B, 2 by 2, GCF, GCF, GCF again. Woo! Right? It's a song. Remember it and you'll always be able to factor. Alright, here we go. Okay, this isn't just an easy factor where I can go x and x. Because notice my first term has to be 8x squared. And when I try and multiply those back together, I don't get 8x squared, I only get x squared. So there's lots of ways. I could have an 8, 1, and a 1 here. That would make 8x squared. I could do a 2 here and a 4 here. That would make 8x squared. I could do a 4 here and a 2 there. So, and I don't want to do all these guessings. And that's what, when you're first taught to factor, you were probably taught the guess and check method. Okay? And that doesn't, I mean, there's nothing wrong with it. I just don't particularly care for it because it takes too much time. And give me just a second. I'm going to pause. Okay, I'm back. Alright, so again, I don't want to guess and check 100 times of what combination, and then you have your combination of factors of 3 that have to go, yeah, it's too much guessing and checking. This technique is a little weird if you've never seen it before, but once you get used to it, it always works. I cannot even imagine factoring with guess and check anymore. Alright, so what you do is you take A, which is 8, times C, which is 3. Yes, I know it's negative, but I don't care about the negative because, again, both are bully is going to take care of it. Right? So 8 times 3 is 24. I need all the factors. 24. 1 times 24 is 24. 2 times 12. 3 times 8. 4 times 6. 5 is a decimal. 6 times 4. I'm repeating. Once you start repeating, those are all the possible combinations. You're trying to find a pair so that you can rewrite B. I'm trying to rewrite negative 10x. Well, I need a pair that make 10. 1 and 24 will not make 10. If I add, I would get 25. Subtract, I would get 23. 2 and 12. If I added, I would get 14. If I subtracted, I would get 10. So that's a possibility. Again, this does not happen very often, but check your other pairs. 3 plus 8 would be 11. 3 minus 8, or 8 minus 3 would be 5. No. 4 plus 6 is 10. So there's 2 ways to make 10 in the middle, which again does not happen very often. C will tell you to make 10 here, I'd have to add. To make 10 here, I'd have to subtract. C will tell you which pair to use. If C is addition, then you use the adding pair. If C is subtraction, you use the subtraction pair. So I know I have to use these two because I need the subtracting pair. So negative 10x is going to somehow, I need to make that out of a 2x and a 12x. Again, your signs. If C is positive, then they both get the sign of B. If C is negative, then only the bully. C is negative, so only the bully gets this sign. 12 is the bully, he gets the negative, 2 gets the positive. Okay, so A times C, I found all the factors. I just rewrote B. I mean, I still have negative 10x there. But now you need to rewrite it in the original problem. So I'm going to have 8x squared minus 3, but I'm going to change the negative 10x in the middle to plus 2x minus 12x. I still have 8x squared minus 10x minus 3. I just rewrote negative 10x as 2x minus 12x. Okay, so that's what rewrite B means. 3 says 2 by 2. If you notice, we just turned our trinomial into a polynomial with 4 terms. Once you get to 4 terms, it's the grouping technique, which says 2 by 2. And you see I literally put 2 terms on the left side of the bar and the other 2 terms on the right side of the bar. Okay, that's what 2 by 2 means. Okay, then next we have GCF, GCF. What the heck does that mean? Well, GCF the first 2 means what can you factor out of there? What do they have in common? They each have a 2 and an x. So if I factor out a 2x, I get 4x plus 1. There's that GCF. GCF, the second side, I'm going to do the same thing over here. These guys both have a 3 in common. And again, I don't care if these are the same, different, whatever. Whatever sign is right after the wall is the sign your GCF has. Always. Okay, so if I divide out a negative 3, I get a positive 4x plus 1. Okay, there's my GCF. So, A times C, found all the factors. Rewrite B, 2 by 2, GCF. And now we're at GCF again. Woo! And all that happens, guys, is at this point, you better have a matching binomial. If you don't have a matching binomial on each side, then you've done something wrong, or the polynomial is prime and can't be factored anyways. Alright, but my GCF again is the common binomial. So whatever's the same on both sides goes there. To get what's left, we're going to divide by 4x plus 1. Cancel, cancel, and whatever's left, in other words, the two GCFs that you pulled, are going to make your second binomial. So 2x minus 3. And we have factored 8x squared minus 10x minus 3 equals 4x plus 1 times 2x minus 3. Okay? And if you look at the graph, this would say that it crosses at negative 1/4. This would say it crosses at positive 3/2. Okay, let's try another one. A is not 1, so to factor this, we have to do the long song instead of the short song. So we have to do A times C. 6 times 7 is 42. I need all the factors of 42. 1 and 42. And you can check, instead of listing them all first, you can list them and check them as you go. I'm trying to make 19. Add would give me 43, subtract would give me 41. That didn't work. 2 and 21. If I add, I get 23. If I subtract, I get 19. So there's my pair. Okay, so I did A times C. I found all the factors. I didn't find them all, but I found one until I kept going until I found one that worked. And now I'm going to rewrite B. So I'm going to take 19x and I'm going to rewrite it as a 2x and a 21x once I figure out the signs. And C will tell me the signs. Since C is negative, they both get the middle sign, which is going to be positive. Oh, Tamsin, I'm so sorry. I'm like, that didn't make any sense. C is negative, so only the bully, my bad, only the bully gets the positive. So 21 will be the bully. He's positive. 2 is negative. So I'm going to rewrite my function. I have 6x squared and a minus 7 on the end. And I'm going to rewrite 19x as negative 21x. I'm sorry, negative 2x plus 21x. Okay, so I did A times C. I found all the factors. I rewrote B. Now I'm at 2 by 2. Watch me now. GCF, GCF, GCF again. Woo! Now, to get the GCF on the left, we look and see what they have in common. They both have a 2, and they both have one copy of x. So that's my GCF. To get what's left, I'm going to divide by 2x. That's going to give me 3x minus 1. On the other side of the wall, I'm going to GCF over there. They have a 7 in common. And I'm always going to take the first guy's sign. So, and now if I divide by 7, I get 3x minus 1. And notice, again, I have a matching binomial on both sides. So that's my GCF again, 3x minus 1. And to get what's left, you factor, divide out 3x minus 1, and I'm left with 2x plus 7. 6x squared plus 19x minus 7 equals 3x minus 1 times 2x plus 7. If you multiplied these back together and simplified, you'd get that back. Okay. All right, and you try one. Hit pause, come back when you're ready. Come on. There you go. All right, if you didn't get that, let's look at y. 3 times 16 is, I think, 48. Oh, goodness. 3 times 16, yeah, 48. I need all the factors of 48. 1 and 48. Add is 49, subtract is 47. I need to make 14. 2 and 24. Add is 26, subtract is 22. 3 is 16. Add is 19, subtract is 13. 4 is 12. Add is 16, subtract is 8. 5 is a decimal. 6 and 8? I know. My brain doesn't work this way anymore. 6 and 8. If I add, I get 14. So there's my pair. So I'm going to rewrite negative 14x using a 6x and an 8x. C will tell me my signs. Since C is positive, they both get the middle, so the middle sign, which is negative. So I'm going to rewrite negative 14x as negative 6x minus 8x. That's just rewriting B. I still have the first and the last term, so I have 3x squared and plus 16. And now I am at 2 by 2, GCF, GCF, GCF again. Woo! Alright, so let's see. The first side, they have a 3 in common and 1x. If I divide by 3x, I get x minus 2. The other side of the wall, they have an 8 in common, and I'm going to take a negative. So divide by negative 8, and I get positive x minus 2. At this point, we should have a matching bino, or we did something wrong, or it's prime. But I do have a matching bino, which is x minus 2. And to get what's left, I divide by x minus 2. And I get 3x minus 8. And it doesn't matter what order you put your factors in. Okay? Alright, so difference and sum of cubes. The songs for cubes go for sum of cubes, meaning both terms are perfect cubes, but you're adding them. Okay? Your song goes bino, trino, plus, minus, plus. See the bino, the trino, and the signs go plus, minus, plus. And then I'll show you how to get the terms in a minute, but that's what the song means. When you have difference of two cubes, and the only difference is they're both perfect cubes, but you're subtracting instead of adding, the sign goes bino, there's my bino, trino, there's my trino, minus, plus, plus, and again, then you just plug in your your A's and B's, and you're done. Alright, so let's look at this. A cubed plus 8. These are both perfect cubes because the cube root of x cubed is x, and the cube root of 8 is 2. Okay, if they're perfect cubes, then you can use your cube sum. This one is going to be bino, trino, plus, minus, plus, because that's what happens when it's a sum. Now, to get your terms, it's really simple. These are your bino terms, x plus 2. Now, my story is they're out doing math parties tonight, okay? So there's a bino party and there's a trino party. When you first do the roots, what you found is who's going to the bino party. Well, they go to the bino party and they get a little bored and they go, I want to go to the trino party. So all they have to do to get into the trino party is get squared. So x comes over, squares himself, and drops into first place. 2 comes over, he's at the end, he likes being at the end, so he comes over to the end, he squares himself, and that makes 4. And then to get the middle, these two kind of come together and multiply, don't worry about signs because I already picked my sign, goes there. And I'm done. X cubed plus 8 equals x plus 2 times x squared minus 2x plus 4. If you look at a graph, see how it only crosses once right at -2? There aren't any more reals. So what that tells me is this, and that's why you stop factoring at this point. If I go ahead and keep factoring, or I couldn't, I'd have to do quadratic formula on that one, but if I did, I'm obviously going to get imaginary answers because I can tell from the graph it's only going to cross once. All right, we're not really interested in graphing. I just kind of wanted you to visualize that. All right, see if they're perfect cubes. The cube root of 64x cubed is 4x. The cube root of 125 is 5. And if you ever need to check it on a calculator, you could hit whatever root you're taking. So if you were typing this in a calculator, you would type 3, and then you would hit your math, and then you would arrow over to num, and no, let me do. Sorry, not math, arrow over to num. You just do 3 because that's the root you're taking. Hit math, and then it's choice 5. And when you do that, your screen should look a 3, and then it'll type a, I don't remember what it types. I'd have to look at the screen. But that's how you get a cube root. Anyway, so these are perfect. It's a difference this time, so that's going to be bino, trino, minus, plus, plus. And you just have to memorize the sign chart. Okay, and then again, here's your bino partiers. And to go to the trino party, they got to get squared. So 4x times itself would be 16x squared, and 5 times itself would be 25. And to get the middle, you multiply those two together, which is going to be 20x. And we're done. Okay? All right, and if you look, there's only one. It's going to cross at 5/4, okay, which is 1 and a little bit. And then again, this one's going to give me 2 imaginaries. All right, you try this one, hit pause, come back when you're ready. And hopefully you got 3. All right, if you did not, check your cubes. The cube root of 125x cubed is 5x. The cube root of 27 is 3. So bino, trino, minus, plus, plus. And my two terms are 5x and 3. 5x squares himself and goes in as 25x squared. 3 squares itself and goes in as 9. These two multiply together and go in as 15x. Okay? Alright, to write an expression in reduced form. Why are we going over all this factoring stuff? Well, I told you, you're going to be factoring, factoring, factoring. Your first step in reducing basically a rational expression is to factor the numerator and denominator, list any restrictions on the domain, cancel like factors, multiply any remaining factors in the numerator together, multiply any remaining factors in the denominator together, and then this will be your reduced expression. Here we go. When they're monomials, a monomial over a monomial, you just do the numbers and the letters separately. 15 doesn't go into 18 evenly, but I can reduce it by 3. 3 goes into 18 6 times. 3 goes into 15 5 times. And then for my letters, I have x cubed. When you do x cubed divided by x to the first, it's x to the 3 minus 1. And you subtract exponents, which gives me x squared. Now you can write it like that, or you can write 6x squared over 5. These are both correct answers. Okay? All right, the other one, the top is a monomial, but the bottom is a binomial. Anytime you have more than a monomial, there's a chance that you can factor. Obviously, I can't do anything on top. It's a mono. But on bottom, 2 terms, there's a GCF. I can pull an x out. If I divide by x, that's going to leave x minus 2. So on top, I have an bottom, and an x minus 2. Now, as far as canceling goes, like this x and this x couldn't cancel because he's a mono, he's a bino. But 3 of these x's can cancel out 1 of those x's. So one of these would get rid of one of these, which makes my answer x squared over x minus 2. Okay? All right, so on top, over here in the first example, these should be easy factors because a is 1. So I don't have to do the whole rewrite b, 2 by 2, all that stuff. I can just get, on top, I'm going to get my factors of 30. 1 and 30. Well, and you don't have to go through them all. Okay? I'm trying to make 1. Well, the factors of 30 that make 1 are going to be 5 and 6. Okay? So on top, I'm going to have a 5 and a 6, x and x. C will tell me my signs. Since C is negative, only the bully gets the negative in the middle. So 6 is going to be negative, 5 is going to be positive. On the bottom, I want factors of 18 that make 3. Well, that's easy. That's going to be 6 and 3. Sorry, and he's using y's and I switched to x's. My bad. So my numbers are going to be 6 and 3. C is negative, which means only the bully gets the middle. So bully 6 gets the minus, 3 gets the positive. So I factor the top and bottom, and now voila, what cancels? The y minus 6's. So what I'm left with is y plus 5 over y plus 3. And I'm done. No, you can't cancel the y's. They're part of binomials. You can't take a half of, unless the whole binomial matches, you can't cancel pieces of it. All right, on top, there's 2 terms, so I'm looking for a GCF, and I can factor out a z, which would leave z minus 3. On bottom, this is difference of squares. Now be careful. Bino, plus and minus. You can't switch the order. Okay, the square root of the first term is 3, so that has to go first in each house. The square root of z squared is z, so that's got to go here and here. Okay? Now, I want so badly to cancel out these 2 terms, but I can't because they actually have opposite signs. So there's a trick. There's a -1 trick. Okay? I'm going to do this on the side. If I had -1 times 3 minus z, and I simplified it, wouldn't that be -3 plus z, which I could then write as z minus 3? Correct? Then it would match the z minus 3 on top. You can factor anything you want, guys. Okay, I'm going to recopy my top. I don't want to rewrite any of those. That one you can rewrite. Addition, you can switch no matter what. But this one I'm going to factor into this. So I'm going to factor it into a -1 times z minus 3. So I replaced this with this. Okay? I replaced this with this. And now, can you see that I have a matching bino on top and bottom? The z minus 3's are going to cancel. So now I have z over a -1 times z plus 3. Now, for whatever reason, people don't like negatives on the bottom. When a fraction is negative, when a fraction is negative, you can put the negative on the bottom or on the top or just in the middle. If you put it in the middle, it's just going to be -z over z plus 3. Or you could just move it up top, -z over z plus 3. Any of these are perfectly acceptable. Okay? All right. On top, we've got difference of cubes. Because the cube root of 8z cubed is 2z, and the cube root of 1 is 1. So the top is going to be bino, trino, minus, plus, plus. My terms are going to be 2z and 1. So 2z minus 1. To get into the trino party, they've got to get squared. So 2z times 2z would be 4z squared. 1 times 1 would be 1. And multiply them together for the middle would be 2z. There's my top. Okay? My bottom is a general trinome, and A is not 1, so I'm going to have to do A times C, which is 6. Factors of 6, 1 and 6 will make 5 if I subtract, and subtract is what I want. So those are my two numbers. So I have to rewrite B. I'm going to rewrite 5Z as 1Z and 6Z. I just got to get the signs. Well, since C is negative, only the bully gets the middle. So 6 gets the positive and 1 gets the negative. And I bring everything else down. 2Z squared minus 3. Now I'm at 2 by 2. GCF, GCF, GCF again. Woo! So on this side, I'm going to pull a Z. If I divide by Z, I get 2Z minus 1. These guys have a 3 in common. I'm taking the positive because that's the first sign. Divide by 3, I get 2Z minus 1. You better have a matching bino or something's wrong, but I do. My matching bino is 2Z minus 1, and what's left is Z plus 3. So on bottom I get a 2Z minus 1 and a Z plus 3. And voila, if there anything matches, any factor matches on top and bottom, 2Z minus 1, 2Z cancels. So what's left is 4Z squared plus 2Z plus 1 over Z plus 3. And that's as simplified and reduced as I can get. Alright, so now try this one. On top we have 4 terms. So for 4 terms, our technique is we're already skip half the AC song. We're at 2 by 2. GCF, GCF, GCF again. Woo! On the left-hand side, I'm going to, they have an x squared in common. If I divide by x squared, I get x plus 2. On the right-hand side, they have a 3 in common, and I'm taking the negative. Divide by negative 3, I get positive x plus 2. My common bino is x plus 2, which would leave x squared minus 3. Now, you might think that you can factor this one more because it's second degree. And if it came out to be like difference of squares or they had something in common, you could, but there's nothing else I can do there. On bottom, there's 2 terms. The only thing I can do is GCF times what's left. And they have an x squared in common. If I factor out an x squared, that's going to leave x plus 2. So on bottom, I have an x squared and an x plus 2. Okay, and now you look for like factors on top and bottom. The x plus 2's cancel. And do not cancel the x squareds. This is part of a binomial. This is a monomial. You can't cancel pieces of one with a piece of another. So that would be as simplified as I can get. Okay? Alright, you try this one. Hit pause. Come back when you're ready. And hopefully you got number 1. If you did not, let's look at why. On top, 2 terms generally means either it's squares, cubes, or GCF. There's not perfect squares, not perfect cubes. So I'm going to GCF times what's left on it, and they have a y in common. Divide by y, I get y plus 3. There's my top in factored form. On bottom, I'm at 4 terms. So we're at 2 by 2, GCF, GCF, GCF again. Woo! On the left side, they have a y squared in common. If I divide by y squared, I get y plus 3. The other side, they have a 5 in common, and I'm going to take the negative. So negative 5, divide, and you get y plus 3. There's my common bino, which is y plus 3, which leaves y squared minus 5. So if I rewrite the bottom as y plus 3 times y squared minus 5, what cancels is the y plus 3. So my final solution is y over y squared minus 5. Alright, so how do you simplify rational expressions? Well, you factor all tops and bottoms. We should say numerator and denominators. Cancel like factors. And reduce. Okay, and we are at homework. So happy homeworking, and I will see you next time.